Okay. So this is the level 2 further maths sample assessment material. So the examples normally release this as well as a specimen paper. And this is paper 1, so non-calculator. So let's have a look at the first question. So the first question is asking us to substitute in 1.3 times 10 to the power of 2 into this expression. So I'm just going to take our out of standard form. So we're subbing in 130. So I've got to do 130, take away 49 for the numerator. And then 130 plus 39 for the denominator. So my calculation is a square root of 81 over 169. So when you square root a fraction, you are square rooting the numerator and square rooting the denominator. So the square root of 81 is 9 and the square root of 169 is 13. Not 189. Okay, so just a little bit of number crunching for question 1. For question 2, they're giving you a mathematical statement, and obviously we need to turn that into an equation. So a fifth of 3a, remember of means multiply, so a fifth times 3a is 35%, so I'm going to put that as a decimal, 0.35, and again of means times of a plus 6. So I'm just solving this equation. So I've got 3/5 a, and I'm going to multiply out those brackets. So 0.35 a, and then 6 times 0.35. Okay, so that would be 2.1. Okay, I may as well turn this one into a decimal as well. So 3/5 is 0.6. I'm all in decimals. Okay, and then I'm going to subtract 0.35a. So I've got 0.25a. And then I'm doing 2.1 divided by 0.25. So different ways you can do this. You can either take the decimals out, so times the top by 100 and the bottom by 100. Okay, or you can actually think about dividing, probably easier. Dividing by a quarter is the same as multiplying by 4. So it's actually the same as doing 2.1 multiplied by 4, which I think is slightly easier. So 8.4. So for the next question, we have got AC and PQ bisect each other. So remember, bisect means it cuts it in half exactly. So this means that B is the midpoint of AC and it's also the midpoint of PQ. So I've got my coordinates of A and C. So I want to start off by finding the midpoint of AC. And to find the midpoint, you average the X coordinates and average the Y coordinates. So I'm going to average 6 and minus 4. And then I'm going to average 5 and 1. So I know those coordinates of B is 1, 3. So remember, 1, 3 is also the midpoint of P to Q. Okay, so we don't know what this is. I'm going to call it X, Y. Okay, and then I can follow the same procedure. So I know if I average my X coordinates, so minus 2 and X, and then divide by 2 because I'm averaging. Do the same with the Y coordinates, so minus 1 and Y, average those, so divide them by 2. that's going to give me my midpoint of 1, 3. So I can just compare my x coordinates and solve that equation. And then do the same for y. So minus 1 plus y over 2 is 3. So the numerator must equal 6. And that makes y 7. Okay, so just a question purely involved midpoints. So just be careful. Lots of people for this question look at gradient. Okay, remember gradient is if it is a perpendicular bisector. So bisecting doesn't necessarily mean that they are perpendicular. Factorise fully. So the word fully always indicates there's more than one thing to take out as a common factor. So look carefully. So I'd separate your numbers, your x's, your y's. So there's no number that I can take out the front. If I look at my x, I can take an x squared out the front. If I look at my y's, I can also take a y out the front. So remember, when it says factorise fully, that means there's more than one variable to take out the front. So x squared times another x squared will give me the x to the 4. And then I need to multiply the term by 3. I've already got the x squared and I've got a y, so I need to multiply by another y squared. So it should have been quite a straightforward question. You could get something like that in normal GCSE. For an algebraic fraction, remember you factorise to simplify. So I can take a 2 out on the top. I'm left with 5x minus y. And then on the bottom, I can take out a 3. And I'm left with y minus 5x. So with this question, obviously we're looking to be able to simplify something. We want a common factor. So I haven't got a common factor here, but hopefully you should notice that 5x minus y looks pretty similar to y minus 5x, okay? However, it's obviously the signs are the wrong way around. So if you multiply by minus 1, okay, so it's a fraction, so you've got to say two the same to the top and bottom. Okay, if you're multiplying 3 things, doesn't matter which one you multiply by minus 1. So either I can multiply the 2 by minus 1, or I can multiply the bracket by minus 1. Okay, so for the top, I'm going to multiply the minus 1 and the 2, and then I'm going to leave 5x minus y. However, for the bottom, I'm going to do it the other way around. So I'm going to leave the 3 and multiply the bracket by minus 1, which then gives me 5x minus y. Now I've got something that I can cancel. So I know that I've got minus 2/3 left. Okay, so that's one way of thinking about it. Another way of thinking about it is if you are in that situation and your brackets look similar, but you know that one of them has got a factor of minus 1, you can just change your mind. Rather than take out 3, you could have taken out minus 3 to make it match the top. Okay, so if you take out minus 3, then you're left with minus y plus 5x. So therefore, it would be the same as the top, even though it's written the other way around. So you can cancel them. Sorry, that wasn't a 5, that was a 2. And then 2 divided by minus 3 is minus 2/3. So 2 different approaches to that question. Okay, but that is quite a common idea where one of the factors will be negative. Number 5. Best thing to do with these sorts of questions is draw it so you know what it should look like. So we've got the origin here. And then the point P is 2, 3. So let's say that's up here. Okay, and we know that this is the radius of the circle. So we want to find the equation, 2 possible equations of circles. Okay, so to start with, both of them are going to need the radius. Okay, so if this is the radius, we need to work out the distance between this point. So remember to use Pythagoras. So this side of the triangle will be 2, this side of the triangle will be 3. So if you use Pythagoras, That gives us root 13. So we know the radius is root 13. Okay, so you've got two options here. Possibility of two circles. It's not telling you where the middle of the circle is. So either the origin will be the middle of the circle, like that, or you might have the 2, 3 is the middle of the circle. You might have a circle like that. Okay, so if the origin is a circle, it should be x squared plus y squared equals 13. So remember, it's r squared on the end. If the 2, 3 is the centre of the circle, it will be x minus 2 squared plus y minus 3 squared equals 13. Okay, so you just had to think about the possibility of those two circles. Okay, so for this next question, we want to work out the value, largest value, where 32n over 3n minus 7 is bigger than 11. Okay, so if we solve that equation, or inequality, should I say? So n has got to be less than 77. So the largest possible value, make sure you read the question on this. Lots of people seem to leave their answer as n is less than 77, but the largest possible value that it can be, because n has got to be an integer because it's the term number, that means it has to be 76 at most. For the limiting value, so the trick with these questions is to take your expression, so 32n over 3n minus 7. Okay, and if you divide each term by n, that gives you 32 over 3 minus 7 over n. Now, if we're considering where n is tending to infinity, so as n gets really, really, really big, 7 over n becomes really, really, really small, doesn't it? So almost 0, which means we can ignore this term because it will be so close to 0 that it will be negligible. Okay, so that means your limit is 32 over 3. Okay, you don't have to put that back as a mixed number. You can leave it as top heavy. Right, here we've got a piecewise function. So we've got a quadratic for domain of 0 to 2, and then a linear expression for 2 to 5. So using the coordinates on the graph, we want to work out the values of A, B, C, and D. Okay, so for your quadratic, the minimum point is going to be important. So it's thinking backwards. If you think about when you have got completed square form and you're trying to find the minimum, okay, you're putting that backwards. So A and B should be relatively easy to find. So if f of x is x minus a squared plus b, remember your minimum point is at these coordinates here, is A, B. Okay, so therefore A has got to be 1 and B has got to be 2. For the linear part of the graph, it's basically asking you to find the equation of this line. So if we work out the gradient, so remember the gradient is the change in y over the change in x. Okay, so if we look at the change in our y coordinates, it's going from 3 to 4, so the change would be 1. And our x coordinates going from 2 to 5, so that would be 3, which gives me a gradient of a third. So if we look at this equation here, then obviously my gradient is c. So c is 1/3. Okay, and then we obviously need the y-intercept of that line to be able to find d. So remember the equation of a straight line is y minus y1 equals mx minus x1. We just said the gradient was a third. And then we need to substitute in a point. So it doesn't matter which one we pick. I'm going to go for 2, 3. So my x coordinate is 2. My y coordinate is 3. Okay, so y minus 3 is a third, x minus 2/3. And then I can just add the 3. So it's going to be minus 2/3. Add 3, so it's going to be 2 1/3. Or 7/3. Okay, so when we're using equation of a straight line, we do normally tend to use top-heavy fractions. Question 8. We need to work out the inverse of minus 8. So remember the whole purpose of an inverse function. So a normal function, we would put our input in as x, and then our y value would be the output. So an inverse function, the definition of an inverse function is the opposite way around. You're putting your output function, you're putting your output in to the function to try and get what the input was. So in other words, it's asking us to solve x plus 4 cubed, and we know the output is minus 8. So if we cube root minus 8, we get minus 2. And then we can subtract 4, we get minus 6. For part B, it's quite a simple composite function. So remember, this means you're subbing h of x into g. So we're putting x minus 5 into the g function. So every time we see an x instead, we're going to put x minus 5. Okay, we then want to solve where that equals x. So if we bring up the denominator by cross multiplying, multiply out the brackets, and then make sure you've got 0 on one side. We can then factorize that. So remember, you're looking for two numbers, multiply to get minus 6 and add to get minus 5. We're going to want minus 6 and plus 1. So then your answer is minus 1 and 6. Okay, for this question, show that y to the 6 can be written in the form a to the k, where k is an integer. So before we put y to the power of 6, we probably want to sort out the powers a little bit. So when I'm multiplying, I'm going to add the powers. So looking at that numerator, let's add 3/4 and 7/12 together. And then on my denominator, I know that's going to be to the power of a half. So you're going to have to add 3/4 and 7/12, and then because we're dividing, we subtract the powers. We want to then take away a half. So if I combine that all into 12ths, so 9/12 add 7/12, take away 6/12, gives me 10/12, which is 5/6. Okay, so I've then got y is a to the 5/6, which means if I'm raising that to the power of 6, I can multiply the powers together and I'm just left with a to the 5. So just some simple indices work as long as you can add fractions together. Question 10 is expanding brackets. Okay, so we've got n plus 2 to the power of 3 minus n squared multiplied by n minus 5. So for 3 brackets, you could, if you wanted to, multiply out all the brackets, but remember you can also use binomial expansion. Okay, So if we write out Pascal's triangle, we're looking at this line here. So remember, it'll be 1n cubed, and then my power of n is going to go down. My power of 2 is going to go up. My next coefficient is 3. My n power goes down, and then multiply by 2. My n power goes down. My 2 power goes up. My next coefficient is 1, and that would be 2 to the power of 3. Okay, so it's actually quicker, I think, than multiplying out 3 brackets. And then obviously we're taking away n cubed plus 5n squared. So I just sort that out a bit. I've got 6n squared, add 12n, add 8, and minus n cubed, add 5n squared. So my n cubes are going to cancel out because I've got n cubed minus n cubed. So I'm left with 11n squared, add 12n, add 8, which was the form that we wanted it in. So it ends up being a quadratic. Okay, question 11 is simplifying surds. So okay, so question 11 is simplifying surds. So remember, you want to break your surds up into 2 factors, one of which is a square number. So I'm going to choose root 100 and root 6 for 600. And then I've got root 6 and root 9 for 54. And root 6 and root 4 for 24. Okay, so that leaves you with 10 root 6 minus 3 root 6 divided by 2 root 6. So 7 root 6 over 2 root 6, and obviously the root 6's cancel out. So you're just left with 7 over 2. Question 12 is giving us a right-angled triangle, and it's giving us the ratio for sine x. Okay, so remember, sine x is your opposite side divided by your hypotenuse. So we know that sine x is the opposite side, so 3a over 2a plus 9. And we also know that it equals 3/5. So we can make an algebraic fraction equation out of that information and then cross multiply. So if I expand the brackets, not 18. I know that 9a has got to be 27. So that leaves me with a is 3. So I'm not actually asked to work out a, I'm asked to work out BC. So I then need to use that to find out what BC is. So I'm going to substitute my a back in here. So that makes this side 9 centimetres. This would be 2 times 3 plus 9, so 15 centimetres. And then it's asking me to work out BC. So obviously you're left with simple Pythagoras. So my hypotenuse is 15. So I'm doing 15 squared minus 9 squared. And square rooting. Okay, so you could square those numbers and take them away. Okay, or you could notice, okay, if you know about the 3, 4, 5 triangle, this is quicker. Okay, a 3, 4, 5 triangle always works. So if you have two sides at 3 and 4, the hypotenuse is always 5. Okay, any multiple of that will work as well. Okay, so if you've got a 3, 4, 5 triangle and you increase every side by a scale factor, then obviously it will stay in the same proportions. So if we've got a side of 9, that's a 3, 4, 5 triangle where all the sides have been multiplied by 3, isn't it? So that's probably quicker, save you precious time in the exam, rather than actually working out what 15 squared minus 9 squared is, and then square rooting. Okay, so we've got some information about a cone. We've got its volume, and we know that the height to radius ratio is 5 to 3. Okay, so think about what that means. Okay, 5 to 3 means that h is 1 when r is 3/5. Okay, so if you simplify the ratio, you'll see why I've done that in a minute. That means we can get an expression for h in terms of r. So that means our radius is 3/5 of whatever h is. So if we've got the volume, 320 over 9 pi, we know that's equal to 1/3 pi r squared h. And we're trying to work out what the radius is. So actually I'm going to change this. I don't want r in terms of h. I want h in terms of r, but obviously you can just rearrange that. It'd be 5 over 3 r. Okay, so because r is the thing that I'm trying to find, I want to have an expression that's just got r in it. So it's going to be r squared multiplied by h, which we now said is 5/3 r. So that's why I've put it that way around. Okay, so straight away I've got a pi on both sides that I'm going to get rid of. Okay, straight away I can see my denominator is 9 on both sides. So I'm going to multiply both sides by 9. So that gets rid of my third and my other third here. So I've just got r squared times 5r. So that leaves me with r cubed is 320 divided by 5. So if I just quickly work that out, that is 64. Okay. And then I want to cube root 64, which is 4. Okay, so my radius is 4. Question 14 is a very simple trig equation. So you should know these values. If you don't, remember there are two triangles. So one is an equilateral triangle that's been cut in half. So if this is 2, because that's been cut in half, that's 1. That's 30, and my other side is root 3. Okay, so because I want a half, I've got the right triangle because I've got 1 and 2. So if I'm looking at sine, then that has got to be the opposite. That has got to be the hypotenuse. Okay, so therefore I'm looking at this angle here, which is 30, to make that the opposite and that the hypotenuse. Okay, so I know that x is 30 degrees. If you use a cast diagram. Okay, so because sine x is a positive number, then sine is positive in the all quadrant and the S quadrant. So this is my 30 that I just worked out. So to get this angle here, I want to do 180 take away 30. So 150. So two answers, 30 and 150. We've then got another trig equation to solve. Okay, it does give you one of the solutions. So for this question, tan is a negative number. So it will be positive in the all quadrant and the T quadrant. So because it's negative, it will go into the other two quadrants. So it gives you one of the solutions. So we know this is 120. which would make the remaining part 30. Okay, so if we want to get to the next one, this one here, okay, different ways of doing it. So you can either do 360, take away 30 to get 330, or you could just added 180 on to your last answer. So, right, I've done that wrong, haven't I? So sorry, that should have been 60. I clearly can't do 180, take away 120. Try that again. 360, take away 60 is 300. My bad. Okay, or you could have added 180 onto your last answer. So you could have also done 120, add 180, which is also 300. Right, next question is on circle theorems. A lot of the questions that do come up on circle theorems are slightly harder than what you see in the GCSE maths paper, so they quite often involve algebra. So with these questions, this is worth 5 marks. The first 3 marks were for working out any angles you could work out. So even if you're not quite sure how to get to the end result, just work out any angle on this diagram that you can possibly work out. Okay, so that's going to be our main method. So the most obvious one is probably this one here, which is 100, because you've got a cyclic quadrilateral here, so therefore they're going to add up to 180 degrees. So we're going to say ABC is 100, and you do have to put your reasons. So angles in a cyclic quadrilateral. Okay, so have a look at what information they've given you. You've also got a tangent. Okay, so whenever a tangent is involved, think about the circle theorems that involve tangents. Okay, so we've got an angle here between a chord, so here's my chord, and a tangent. Okay, so I should know that alternate segment theorem is going to come into play. So the chord subtends to this angle here, so makes a triangle of 2x. So therefore that's going to be 2x as well. Okay, so ABE is 2x because of the alternate segment theorem. Okay. I therefore can work out this angle here because of angles on a straight line. So this angle here is going to be 180, take away 100 and take away 2x. So in other words, 80 take away 2x. So CBF is 80 take away 2x. And that was just angles on a straight line. Okay. Also look for other things that give you in the question. So we've got these lines here that show they're equal. So it's formed this isosceles triangle in BCF. So that will probably be relevant as well. Okay, so I can work out what this angle here is. So BCF, using my isosceles triangle, is 180, take away my top angle, which was 80 minus 2x. And then because it's an isosceles triangle, both those angles will be the same. So that leaves me with 100 plus 2x over 2, or 50 plus x. I'm just going to put in brackets isosceles triangle. Okay, so if this is 50 minus x in here, I've now got 3 angles on a straight line again. So I know that 2x, add 2x, add 50, add x, has got to equal 180 degrees. So again, angles on a straight line. Okay, so I've got 1, 2, 3, 4, 5x. I'm going to move the 50 over, is 130. Okay. So then if I divide that by 5, then I've got 26 degrees. Okay. So in this question, you probably want to highlight the word decreasing function. So decreasing function is a function where the gradient is always negative, or a portion of the graph, the gradient is always negative. Okay. So therefore, if I'm thinking about gradient, I know I have to differentiate. So multiply by the power, so 2/3 times 3 is 2. And take 1 off the power. Do the same for the second term, so 7/2 times 2 is 7. And then take 1 off the power. So this gradient is always negative. So therefore 2x squared add 7x is negative for these values of x. Okay, so like any quadratic inequality, you should be thinking, I'm going to draw a graph. So if we factorize, my roots are going to be 0 and minus 7/2. Okay, and this is always negative underneath the axis. So for this part here. So if I read off any point on that curve, it would be between 0 and minus 7/2. Okay, so that's my values where my graph is a decreasing function. So just remember, decreasing function, basically differentiate and make that less than 0, solve the inequality. Increasing function, obviously the other way around, make it bigger than 0 and solve the inequality. Okay, so let's have a look at this question. A, B, and C are transformations given to you in this strange table format. Okay, so let's just have a look at what these matrices would be. So for matrix A, okay, we're going to start off drawing our unit square. I would always put your vertical vector in a different colour, so it makes it easier to see. Okay, and then this is a rotation 90 degrees anti-clockwise. So if we turn this 90 degrees anti-clockwise, this vector here comes onto this axis here. And then the purple one comes down here. Okay, so we end up with our red or pink vector is 1, 0. And the purple one is, sorry, my bad. No, let's try that again. Let's cut off the beginning anyway. So let's have a look at this question here. We've got A, B, and C are transformations given to you in a strange table. But let's have a look at what each matrix would be. So let's have a look at matrix A. So if you draw the unit square, make sure your horizontal and your vertical vectors are in different colours, so it makes it easier to see. So if we're rotating that 90 degrees anti-clockwise, it takes my purple one to there, and my pink one goes to the y-axis, so it'll become there. Okay, so my pink vector has actually become 0, 1. My purple vector has become minus 1, 0. Let's have a look at B. So B, we've got, if we draw the unit square again, make sure the Y one is in a different colour. This one we're reflecting in the x-axis. So it's going to go down there. Okay, so actually your pink vector has not changed, so it's still going to be 1, 0. And my purple vector has moved to 0, -1. Okay, and then C, what we're trying to show is that if we do transformation A followed by B, then we're trying to show that it becomes a single reflection. Okay, so remember, if you're doing a transformation A followed by B, we do the matrix multiplication the opposite way around, so BA. So we want to work out what BA is. 1, 0, 0, -1. 0, -1, 1, 0. Remember with matrix multiplication, so to get this first one here, it's in the first row and the first column. So go along the first row, down the first column. So 1 times 0 and 0 times 1 still gives me 0. This one here, remember we go along the first row and then down the second column. So 1 times -1 is -1, and then we're adding 0. So it's just -1. Down here, we're in the second row but the first column. So we're going to go along the second row, down the first column. So that would give me 0 times 0 and then -1 times 1. And then for the last one, we're along the second row, down the second column, which also gives me 0. So now we just need to see whether this matrix is a reflection. Okay, so if we just draw what it would look like. Okay, so my pink vector has gone to 0, -1. Pink vector, sorry, wrong colour. So my pink vector has gone to there. Okay, and then my purple vector has gone to -1, 0. So here. Okay, so you can see that is a reflection in the line y equals -x. Okay. So I'm just going to summarize it as a reflection in y equals -x. Okay. Next question. We have got a triangle, we've got all the lengths in surd form, and we're trying to find the angle CAB. So this is a question on the cosine rule. Okay, so remember a squared equals b squared plus c squared minus 2bc cos A. Okay, so A, B and C are as follows. So a lot of expanding brackets here. So A is 2√6, so we want to square that. B is 3 plus √5. C is 3 minus √5. And then minus 2, 3 plus √5, 3 minus √5, cos A. So 2 times 2 is 4, √6 times √6 is 6, and 4 times 6 is 24. For this one, remember you should do FOIL, so this is the same as 3 plus √5 multiplied by another 3 plus √5. So if you apply FOIL, we've got 9 plus 3 √5, another 3 √5, so 6 √5, and then √5 squared is 5. For my second one, obviously that's going to be the same, the signs are going to change. So we've still got 9, this will be minus 6 √5 instead. Add 5. Okay, I'm just going to leave that 2 there. So this would be the difference of 2 squares. So 9, so your plus √3 and your minus, sorry, your plus 3 √5 and your minus 3 √5 are going to cancel out. And just have -5 cos A. So let's sort this out a little bit. So my 6 √5 and minus 6 √5 cancel out. So you've just got 9 add 5 is 14, add another 14 is 28. Okay, and then you're subtracting 2 times 4 is 8 cos A. Okay, so to rearrange that, 8 cos A can go over there equals 4. So we've ended up with cos A is 4 over 8, which is a half. So therefore, if you know your triangle, okay, A is 60 degrees. Okay, so again, as previously, draw the triangle. That's 2, that's 1. So because it's half, and we want cos, this has got to be the adjacent side. And that's the hypotenuse, which is why it was 60. Okay, next question is nice because it tells you what to do. So by multiplying through by x to the power of a third. So remember, you add the powers when you're multiplying. So for the first term, we're doing 2/3, add 1/3. In fact, I'm going to write that line out and make it clearer. Okay, so we're just adding a lot of powers together here. So 2/3 of 1/3 is obviously 1 whole 1, so that's just x. 1/3 add minus 1/3 is 0. So actually anything to the power of 0 is 1. And this one, we've got 5/3 add 1/3 is 6/3, which is also known as 2. So that has really simplified the equation for you, hasn't it? Okay. So then I'm going to collect it all on this side actually. So 6x squared minus x minus 1. So if we factorise that, so minus and plus, we've got x is minus 1/3 or x is a half. That's quite a nice question actually. I liked it. Right. Finding the equation of a normal. Okay. So remember, as soon as you see anything about tangent or normal, you should be thinking to differentiate because that will give you the gradient function. Before I differentiate this, I'm going to rewrite it as 14x. Okay, and then I can't have an x squared on the bottom, so you're going to have to move that and make it x to the power of minus 2. So remember, when it's a reciprocal, it's a negative power. So now you can differentiate it. So 14, and then 3 over 2 times minus 2 is minus 3. And then subtract 1 off the power to give x to the minus 3. So you can now put it back because we're going to need to sub into it as over x cubed to make it easier. So we want it at this point where x is a half. Okay, so remember when you find dy dx, you're working out the gradient of the tangent. So 14 minus 3 over a half cubed. Remember, a half cubed is an eighth, so just cube the top, cube the bottom. So we're doing 3 divided by 1/8. And if we're divided by 1/8, it's the same as multiplying by 8. So we're doing 14 minus 24 is minus 10. So my gradient of my tangent is negative 10. Remember, your normal is perpendicular, so you want to do the negative reciprocal of that number. So 1 over 10. So the equation of the normal is just like the equation of any other straight line. So we now know the gradient is a 1/10. And we want a point it goes through, and obviously it's going to go through the same point up here. So a half 13. So y minus 13 and x minus a half. Okay, now ask for it in the form ax plus by plus c equals 0, where a, b, and c are integers. So it doesn't want any fractions in your equation. So first thing I'm going to do is multiply it by 10. to get rid of this 1/10 at the front. Okay, I then also need to multiply it by 2. To get rid of this half. Okay, so if you put that all on one side, you've got 2x minus 20y plus 259 equals 0. Okay, so that form just means put everything on one side and make sure there are no fractions. Okay, this last question is an identity question, sorry. So it doesn't have the identity symbol, but it's the same as the questions that look like this, which I think makes it harder to spot what to do. Whereas actually, if it was written like this, I think more people would do what you do with identities. Okay, and what we do with identities is we expand the brackets and equate coefficients. So I'm going to multiply out these brackets here. I've got b squared x squared, so remember it's bx plus c multiplied by another bx plus c. So b squared x squared, 2 lots of b, c, x, and then c squared. And then go double all of that. Okay, and then I'm just going to put it in the same order as the question. So they've got the constant, the x term, and the x squared term. So my constant, I've got a minus 2c squared. Okay, my x term, I've got minus 4bcx. And my x squared term, I've got 2b squared x squared. So we're equating coefficients now. So I'm going to go for the easiest one, which is the x squared. Okay, because the x squared coefficient has only got one variable in it, so it's only got b in it, whereas the others have got b's, c's, a's. Okay, so I know if I compare these two, okay, my negative 18 has to equal negative 2b squared. So if b squared equals 9, b is 3. If we do the same thing with the x term now, I have 3 lines for this one. Okay, so I'll do this over here. So if we equate the coefficient of x, we've got on this side negative 12. And here with 3 lines, we've got negative 4bc. But I just worked out that b was 3. So I can substitute that in to get minus 12c. So therefore c has got to equal 1. And then if we do the same with the constant, I'm going to circle the constant. Then we know that 7 has got to equal a minus 2c squared. And I've just worked out what c is, so I can sub my c as 1 in there, which gives me a is 9. Okay, so if it wants it in that form, I can sub a, b, and c back in there. So a was 9 minus 2, b was 3, c was 1. Okay, so an identity question won't always have an identity symbol, but think about that process. It's a much easier way of completing the square. Okay, you could have actually completed the square, but it's quite a complicated one. So it's much easier to treat it as an identity. Okay. And that is the end of this paper.